Alright, number 6, we've got a lot to do here. First, we need to show that the derivative is in fact this right here. And then we got to use the first derivative test to find all of the extrema. Alright, so derivative part's not that hard. They give us the answer. We just have to get there. So it's a product rule. So here we go. The first times the derivative of the second. We have a chain rule because the inside is negative x. Plus the second times the derivative of the first. Alright, well that doesn't quite look like the answer they gave us, so let's clean this up a little bit. Let's make this like that. And 3x squared e to the negative x, so I have my x's first. Alright, looks like the final answer has been factored. So what can I pull out? Let's see, they both have x's, so I can take an x squared out, and they both got an e to the negative x, so I can take that out as well. So I'm going to take out an x squared and an e to the negative x. And what do I have left? Well, I've got a negative x. And then I've got a 3. And, oh, voila, we did it. Alright, so there's my derivative. And now I've got to use the first derivative test. So first derivative test is basically a sign chart. You need to find where the graph changes direction. So you need to find when the slope changes from positive to negative or negative to positive. If it changes from positive to negative, we know that we've got a maximum. And if it changes from negative to positive, we know that we have a minimum. So first things first, let's find the critical points by setting this thing equal to 0 or undefined. There is no way the denominator would be 0, so we don't have any undefined. So just when it equals 0. So when will the first factor equal 0? Well, anything times 0 is 0, so the first factor will equal 0 when x is 0. And when will the second factor equal 0? Well, that will be when x is 3. Alright, so we need to make a sign chart. So we've got zeros at 0 and 3, and then we're interested in what happens before 0, what happens between 0 and 3, and what happens after 3. Alright, so we pick a number between negative infinity and 0. How about negative 1? Alright, let me give myself some room here. Oops. Alright, if I pick negative 1 squared e to the negative 1 is positive 1 times negative 1 plus 3. I will get, let's see, this will be positive, and this will be positive, so this will be positive. Okay, let's pick a number between 0 and 3. How about positive 1? 1 squared times e to the negative 1 times negative 1 plus 3. Alright, let's see. 1 squared times e to the negative 1. That's still positive because e to the negative 1 is just 1 divided by e to the 1. Negative 1 plus 3. So these are both positive, so I've got a positive value. Alright. And then I need a number between 3 and infinity. How about 4? That sounds good. Alright. 4 squared times e to the negative 4 times negative 4 plus 3. This is positive. Negative 4 plus 3 is negative, and a positive times a negative is going to give me a negative. Alright, so I've got increasing, 0, increasing, 0, decreasing. So what that looks like is increasing, 0, increasing. Hold on, let me redo that. Alright. Increasing, 0, increasing, 0, decreasing. So I've got a point of inflection, it looks like here, not a max or a min because it stays increasing. But here I've got a maximum, a local maximum, because it changes from increasing to decreasing. So f of x has a local max at x equals 3 because and this is important, f prime of x changes sign from positive y'all know what I'm trying to say to negative.